This is GATE 2014 question number 15, which states that at a given temperature T, the average energy per particle of a non-interacting gas of two-dimensional classical harmonic oscillators is dash kBt, where kB is the Boltzmann constant. So two things to note is that it's a classical harmonic oscillator, it's a two-dimensional classical harmonic oscillator, and it's a non-interacting gas. So non-interacting gas is mostly the classical, generally the Maxwell, which follows the Maxwell-Boltzmann statistics and all these things, and it's a classical gas, so it's fine. So it's also given in here also, it's a classical harmonic oscillator, and it's a two-dimensional, so it is restricted to the 2D domain. So how to proceed for the total amount of energy or the average energy of the system is through the law of equipartition of energy. So what we have first written is the Hamiltonian or the energy of the 2D harmonic oscillator. That is classical 2D harmonic oscillator, where H is the Hamiltonian or the energy, and it is restricted to 2D. So here it is X and Y dimension. So it can be written as the classical harmonic oscillator typically is written like this. It is px square by 2m, the kinetic energy term, plus half m omega square x square, the potential energy in the x, and py square by 2m plus half m omega square y square, where m is the mass of the system, px and py are the momentum in the x and y direction, omega square is k by m, where k is the spring factor, the way the potential and kinetic energy is being written here in the x and y direction. So how many degrees of freedom which is seen here? Although it's a two-dimensional classical harmonic oscillator, but the degrees of freedoms are 4. 4 degrees of freedom can be seen. So one is this px, py, and this particular things, the energies, the potential energy term, the x square, half omega square y square, and half omega square x square. So 4 degrees of freedom can be seen over here. So according to the law of equipartition of energy, the total energy is being equally partitioned among each degrees of freedom. So this particular thing states that total energy is partitioned among several degrees of freedom. DOF is the degrees of freedom, and each degree of freedom will have half kBt amount of energy associated with it. So the average energy therefore becomes, and this is the average energy for this harmonic oscillator, or oscillator, is nothing but the degrees of freedom, number of degrees of freedom, that is 4 into half kBt, which comes out to be about 2 kBt. So 2 kBt is the correct answer to this question, and it is the dash kBt, so it will be only 2. 2 will be the correct answer. This is a numerical answer type question. So what we have done here is that the energy we have written, and we have seen that there are 4 degrees of freedom which we can see if we restrict it into two-dimensional part. So to translational, we can see it through kinetic energy part. There are translational freedoms, and through the potential energy also there are 2 degrees of freedom which are coming. So that gives you total 4 degrees of freedom. Using the law of equipartition of energy, we have seen that the answer of the average energy per oscillator comes out to be about 2 kBt. So 2 is the correct option. So 2 is the correct option because the answer was 2 kBt. Thank you.